Watching this on Wednesday from home. We're going to work through this packet and we're going to do just a few pages. I've got the timer set on my phone so that I will not take more than 12 minutes. As soon as 12 minutes is up on my stopwatch, I will stop this video. Okay, so let's just go ahead and work through it. This is where we're going to be creating equations, comparing equations, super familiar to what we did yesterday in class. So we have Jim attending a sporting event. A ticket is $28. He also purchases concessions, right? Concessions are food at the event. Concessions cost $4 each. Okay, so anything he buys at the concession stand is $4. Hot dog, $4. Popcorn, $4. Soda, $4. Everything's $4. So we're going to write an equation in slope-intercept form. Let's remind ourselves that's y equals mx plus b. That gives the total cost y for him to attend a sporting event after purchasing a certain amount of concessions. So we're going to say y equals, and we know it's $4 per concession. Okay, these concessions can be repeating, meaning maybe he buys more than one thing, right? Who buys a hot dog and doesn't get a soda? So we're going to say 4x, because this is repeating. We've done this before. And then it's going to cost him a one-time fee of $28. So this is our equation to describe how much it might actually cost him when he goes to this sporting event. Our slope, remember, is this, and our y-intercept is that. So my slope is going to be 4, or 4 over 1. And my y-intercept is going to be 0, 28. This should all be familiar. Let's interpret the slope and y-intercept. Okay, so the word interpret means is what does each value represent? Right, so we're not talking like, oh, I'm just going to say 4 and 28. I'm going to say 4 is, and I would say 4 represents the cost of each concession item. Right? So my slope is going to increase $4 every time I go back to that concession stand. Right? If I'm by myself, maybe I go twice. If I'm with my kids, I probably go 14,000 times. The y-intercept represents the one-time ticket fee. Okay. Let's go ahead and put up here in a slope that this can be a repeating value. Right? Every time I buy something, I multiply times 4 again. Okay? So we have one time, which is the y-intercept. We have something that can repeat, and that's going to be my slope. Let's turn the page. Now we have a booster club. Same college, Brown College, that sells souvenir hats during each event. The table and graph below, each model, the cost, including shipping, of purchasing so many hats to sell from 2 different online stores. Okay, so you can buy these, right, either at this store called Sports Pro or this hat, or this store, okay? So this is the purchasing for them, right? So if they're gonna sell hats, they want to go to the place that can give them the lowest price per hat, right? That's business 101, right? You have a product. Let's say I spend $7 to buy a pencil. I know they're not that expensive, but if I did, $7 to buy a pencil, I would want to sell it for $8 so I could actually make money, right? So that's how businesses make money. So they want to sell hats, but first they have to purchase them in order to sell them. Okay, they have to have them in their souvenir shop or their bookstore. If you've ever been to a college, it's called a bookstore, and they have all sorts of shirts and memorabilia, lanyards, bumper stickers, coffee cups, all the things. Okay, so we have to figure out which place, Sports Pro or Fantastics, sells them cheaper. So let's create an equation here. So let's figure out how much are they paying per hat. How much does the school pay for this company to make the hats? So let's see here. From here to here, it goes up 150. From here to here, it goes up 150. From here to here, it goes up 150. So remember, our slope is change in y over change in x. So my change in y is 150 hats, $150, and my change in x is it's going up 10 hats each time. So I have 150 over 10, which tells me that in order to purchase a hat, they have to pay $15 per hat. Okay, so the school buys it for $15. They're probably going to sell it for more so they can make a profit. Fantastics is a little different. I don't have a nice table. I have a graph. Okay, so let's go ahead and fill this in. This goes up from 100 to 1,000. So I'm going to say if I go by hundreds, 2, 3, 4, 5, 6, 7, 8, 9. Yep. So that's going to be 200, 300, 400, 500. Okay, so we've got the total cost here. And then number of hats also goes up by tens. I'm not going to put all of the other numbers in here because it gets a little too scrunched, but we know that this would be 30, 50, 70, and 90. So let's figure out how much they pay per hat. So my slope here looks like it goes up 100 and for every 10 hats. So that's going to be $10 per hat. Cool. So this place seems cheaper, right? $15 per hat, $10 per hat. So let's look here. Which store sells their hats for the cheapest price? Clearly, Fantastics does. Right? How do we know? Well, Fantastics is only $10 and Sports Pro was $15. So Sports Pro charged $5 more per hat. Right? We can all figure out math pretty quick when it comes to spending money. Now we want to know the lowest shipping rate. So that shipping rate is going to be how much it costs before we even purchase any hats. So before I purchase any hats, I have to spend a certain amount just to get them to me. So that's going to be my y-intercept. So how much do I have to pay for Sports Pro? For shipping, $100, right? And then if I look down here at Fantastics, how much do I spend before I get any hats? Shipping, $200. So which store has the lowest shipping rate? Well, that's going to be Sports Pro. And how do we know that? Let me check my timer. We know that because Sports Pro or Fantastics charged $100 more $100 more to ship. So now we have a decision to make, right? One of them costs less per hat, but the other one costs less for shipping. So this is when you have to make decisions about, well, which is the best case for me. Okay, suppose the club wants to purchase 50 hats. Which store should the club choose in order to spend the least amount of money? All right, so if I want to buy 50 hats, right? And I know that this is $15 per hat and $100 to ship. And this is $10 per hat and $200 to ship. Well, I can create a couple of equations. See what happened there? So we've got Sports Pro and we've got Fantastics. Okay. Sports Pro is $15 per hat plus $100, and Fantastics is $10 per hat, but it's $200 to ship. So if I want 50 hats, I'm going to put that number 50 in here for X and see which one's cheaper. So I'm going to have 15 times 50 plus 100. Ooh, that's going to cost me $850. And if I go to Fantastics, it's 10 times 50 plus 200, and that's only going to cost me $700. So even though it's more to ship, I'm going to end up saving money per hat to overcome that cost. So which store should the club choose? In order to spend the least amount of money, they're going to want to choose Fantastics. And then mathematically explaining my reasoning, I'm just going to draw an arrow and an arrow because I did. All right, what's our time? We're at 11 minutes, 32 seconds. So we will stop right there, okay? Hopefully you're finishing up your e-learning and you can go out and play in the snow. Okay, thank you guys.